Right. Morning, everyone. Thank you for coming, and big shout out to HackerCon. You guys are this is an awesome con, and also a big shout out to Adrian. The fact that he's sitting here, I think this video is already out, so you can watch it. Uh, the title of our talk is "Gone in 60 Minutes: A Practical Approach to Hacking an Enterprise with Yasuo." And Yasuo is a tool that we wrote, and we'll talk about it in a while, most likely. Right. My name is Saurabh Harit, and I'm a director of security research at Security Compass. We are a pen test company based out of Canada. It's cold, we shiver, fat finger stuff. Pen tester by day, and that's it about me.
Hi everyone, I'm Stephen Hall. I work with Saurabh as a security consultant at Security Compass. You can see me in Toronto wearing the same Santa hat throughout the year. I get crazy looks on the subway. It's actually quite fun. Other than that, not much else really.
All right, so just to set the record straight, we are not going to be dropping any ODAs here, no shells, but we'll be talking about how to get a shell. So the scenario is that you're on a red team engagement or on a network pen test where you need to be stealthy. You've bypassed physical security. There are several ways of doing that. I mean, how many of you have turnstiles on rotating doors in your office? Anyone? Anyone has rotating doors? You're the only one secure, right? So like without that, like we've done a lot of physical security assessment, and it just becomes very easy if there are no rotating doors to bypass physical security. We won't be getting much into that out of scope for this talk. We've seen some clients implement NAC, so network access control. I don't know if how many of you guys do that. But there's certain ways of bypassing NAC. Again, this is out of scope of this talk, but from my own personal experience, the best thing is if it's a large enterprise, just look for unprotected NAC ports. There are thousands of NAC ports, and if you roam around, look for unprotected NAC ports. So if you see like a wireless router hanging from the roof or lying on the ground, that should give you access to the network. Easiest way to get through it. Sorry? Printers. Yeah, you can spoof MAC address from printers, and that should do as well. What next? So you bypass physical security, you bypass NAC, and the part of engagement is for you to get the highest level of privileges on the network, or say get access to PCI data. So what are you going to do next? Typically, if you're crunched with time and you have like 5,000-6,000 IPs to scan, the first intuition is to run Nessus, which basically is probably not a good idea, because if you're trying to be stealthy, and a generic vulnerability scanner like Nessus will light up any network security device like a Christmas tree. So the problem is that we can't use a network vulnerability scanner because we want to be stealth. We have to be stealth and quick because we are either a bad guy who basically bypassed the physical security, got access, so security will be on your ass, or you have to, on a red team engagement, you pretty much have to be really quick, stealthy, and get out of there as soon as possible. You can really use Google Docs. How many of you used Google Docs? Right, so like directives like site, link, you can use them to gather information about your target, right? Which you can't unfortunately do on an internal network pen test, right? So that option is out as well. So you have to somehow map the attack surface, map the applications on that network. So where do shells come from, besides from ocean? A guy I used to work with, Rudolf Temming from Peterva, who wrote Multigo, he used to say that it's not about what, it's about where. And I think the message here is that, well, it's not 1980s anymore. No matter how much we moan, things are getting better. So if you look at network security devices, they're getting smarter. There is proactiveness in network security admins. So like you will generally find the network security device is configured in a decent manner. Like I said, they're getting smarter. So if you are pumping traffic through, they're going to detect it, and then a lot of time you'll find yourself being shunned on the network, right? So the idea here is to find that one particular server, one application, one web service that could let you pwn it, and then you can get access to the network. Unfortunately, once you have access or pwned a server, it becomes really easy to pivot through the networks and then gain access or become a domain admin or enterprise admin. That part is still weak. How many of you do pen tests? Right, so this is going to be interesting for you. I mean, you all know about this thing, so your turn.
Thanks, Rob. So, anytime I see Tomcat, I do that little dance inside because I know this is automatically going to get me access to whatever I need, unless they've done something right, which is not often, but it does happen. So, if you don't know what Tomcat is a application manager that lets you deploy your applications and serve them to either the internet or your internal company. Normally, they have default credentials because developers deploy them and go, yeah, we'll fix this later. This is just to test this one thing, and then they forget about it. So, what do you do with it? You follow their steps. You deploy your own application, which you can either deploy a Metasploit interpreter, or I prefer lighter JSP shells that just give you command access. That way, if they have AV on the box, they're not normally detected that way. JBoss is the same thing. They're just different ways of doing it, and also these have default creds of admin, so also not very hard to guess what box or guess how to get on this box, and you deploy either the same interpreter shell or a lighter shell, or if you have something you wrote yourself, you deploy that. How many here know what Hudson Jenkins is? So only 3 people know the joys of what this wonderful program can do.
I scanned it and found it. I don't see it very often, but I've found it before. I had to go Google it up and figure out something to do with it. Yeah.
So, Hudson Jenkins is a build automation tool, and the highlighted section at the bottom is the most interesting part. They have 2 ways of giving you an interactive shell by default on an installation. You literally click either of those links, you compile your Java or Groovy, and you run it. You don't need to upload anything. This is default installation. Yep, there is also no Metasploit module for it. Fun times when you come across this as well, because this also runs either as system or root. I've mostly seen it as root on Linux boxes. So, the top shell is the Hudson Jenkins. That is literally all the Java Groovy you need to exploit the box and get the shell back. And the bottom one is our favorite Tomcat JBoss, using the Ludanium shell, default NT system. I'll let Saurabh talk about the next couple of ones.
Right. So these are some of the popular applications. I think if you're a pen tester, these would be some of your favorite applications, or more, I would say more popular applications that we normally come across on the network and then pwn them. How many of you have come across AD Manager Plus? Right. So I was doing a pen test, and it was one of those pen tests. Actually, I don't know. So I was doing a pen test, and we were in a kickoff meeting. So it was me, some sales guys, some guys from the client side, and we were sitting in a conference room, and obviously it was a sales meeting, so I got bored, and it was a kickoff meeting, so I plugged myself on the network, and I started looking for applications, and by luck or coincidence, I came across AD Manager Plus. So turns out someone installed AD Manager Plus. This is a third-party tool, allows you to integrates with the Active Directory and allows you some advanced management, so you can automate some stuff, basically it's like having GUI version of Metasploit, which is lame, but some people like it. again, this when you install it, it installs with default credentials admin. You find this thing, you create yourself a domain admin, and then the fastest pwnage ever, like during the kickoff meeting, your domain admin, I didn't know what to do for next 10 days. So, how many of you heard of Cyberome UTM? It's apparently a network security device and exposes a web interface. It's Cyberome Unified Threat Management. I was doing an external network pen test, and it was one of those pen tests when the client gives you 10, 15 IPs. There's nothing running on 11 of those IPs. A VPN port open on one IP. There's nothing much there. So I started looking around. I came across this security device, and I did not expect anything from this device, but it was configured with default passwords. So once you get access to it, I reported 2 ODAs, I think 2-3 years back, never heard back from Cyberome, so I made it public. First, it gives you remote command execution, and the second vulnerability is actually much more lucrative than RCE on this device. So what happens is, due to some fucking weird reason, this device connects to Active Directory to pull some data. And so not just that, it's got a test button, so which basically you can use. You can click on the test button to see if the connection is successful with the Active Directory or not, right? So what could go wrong there? Anyone? I'm sorry? Password is actually stored on the client side. God knows why, but just right-click on the page, view source of the page, the password is right there. Since it's a network security device, it's probably configured with a high-privileged domain user. So again, easy pwnage there. And I actually didn't even know what to recommend to the client. You guys are okay. If you can just get rid of this network security device, things would be fine. Is that you again?
So, what is Yasuo? As this talk continues, you're probably going to say some of this sounds familiar to RAR. And the concepts are, it comes from the same roots, but not quite the same end result. So, we wrote it in Ruby. It took us, for us, a long while to write. We're not programmers, so we didn't write it on a flight to a con and be like, hey, we wrote this and we released it here. Congratulations. No. It took us time and testing to get a somewhat workable version running. It is not an application vulnerability scanner. So what it does is it helps you identify applications that have potential vulnerabilities in them. We currently support pretty much most of the Metasploit modules that are for web applications. And we're slowly working on adding more as we go along. Why did we write this? Because if you search exploitdb for remote code execution in web apps, you get about 12,000 for remote code execution, SQLI, local file inclusion, stuff that can give you access and shells on a box. Yeah. So I can barely remember what I had for breakfast, much less like 12,000 different exploits that I can run to get a shell on a box. So we wrote this to help us find that one box on the network that you could possibly exploit to gain that access and move on with your pen test. A world without automation. I like cats, so we have a cat playing with my computer. So before we wrote this tool, we had to do everything manually, or you had little scripts that you hop together to look for Tomcat, JBoss, that stuff. And it takes you a while. So you'd go through and you'd see, oh, that port looks interesting, and you hit it, and you say, oh, maybe, maybe not, and you move on. So after we wrote this tool, one client engagement, we were scoped for about 5,000 IPs. We ran Nessus against that for just to cover your basis, and it took about 24 hours. It was long and painful.
And figured all the network
security fight.
Yeah, and everybody knew we were there. With Yasuo, the client asked us to try a bit more stealthy approach, and they gave us their entire network range to run against, which was a /16, class B. And we did. It finished in about 2 hours against the whole range, and we may have set off 1 or 2 alarms, but not as much as we did with Nessus. And from that 65,000 ranges, from those 65,000 IPs, we found about 25 hosts that had applications on them that we could pop. And we did, and we got domain admin in what, a couple hours? Yeah. So went from 24 hours of scanning Nessus to less than a day's work to owning the network. I found that useful. I got to sleep more, which was nice for that kind of project. So what's currently out there? There are stuff out there that can be configured to do stuff similarly. There's NIC2 Nmap scripts. RAR can do some of this as well. But what we focus on is helping you find those applications that have exploits out there. So like all of the stuff will say, hey, this is here. But like what Yasuo does is say is, this is here, and it could be vulnerable to this. So it helps you figure out that, hey, I can at least look at this and look in the right direction for that exploit.
Right. So we looked at some of the very popular vulnerable applications that are easy to find. I think even Nessus picks them up. And then we came across we talked about some of the unpopular applications, but they're still there on the network, right? So we came across them. So the point that I'm trying to make is that there are not just 3 or 4 popular vulnerable applications that you could point to get access to a server. There are over 12,000 if you look at ExploitDB. So what we did was we searched through ExploitDB, we crept for malicious file upload, RFI, LFI, SQL injection, remote code execution, and then 12,000 entries came back. And that's when we thought that it'll benefit everyone to just write something that could find those kind of applications. What we did not think of is that how difficult it would be to just grab signatures of the application. So currently we support, like Stephen mentioned, around 115 applications. All of them have exploits in Metasploit. So you can Yasuo can find it and you can go ahead and exploit it. We just wanted to target vulnerable, exploitable third-party applications that you can find and pawn on the network. On the other hand, if you're a network admin, you can run it on your network and then find those applications and get rid of them. And I hope not. Right. Exploring Yasuo. So we've got a few options here. -F. Actually, let's start with -R. -R takes an IP address or IP range, CIDR range, pretty much the same format as Nmap. And once you feed it the network range, it starts a port scan using Nmap libraries. So it does a port scan on web-based ports or whatever ports you specify, and it saves the output in XML format on the disk. If you don't want to use Yasuo as a port scanner, you can do your own Nmap scan. Just have to save the output in XML format and then feed it to Yasuo with -F option. So -F nmap output.xml. Once it gets that, starts parsing through the XML file, looks for all the open ports, and within those, it starts looking for all the web-based ports. So like ports like HTTP, HTTPS, HTTP alt, WebSM, so on and so forth. It looks for all those ports and creates like a preliminary URL, so IP address, port number. So these would be all the target ports. After that, it starts reading the default application signatures from default path.csv file that comes with Yasuo, and starts appending signatures to the application, to the initial URL, and then sending requests to the server. Depending on what response you get back, it tells you if the application is there on the server or not. Now, rest of the ports, rest of the switches are standard to Nmap. So -N is for no ping. If you don't want to ping, say if the network is being filtered or ICMP packets are not allowed. dash P to specify ports, dash uppercase D to specify all the default ports, dash A will just scan for on all the ports. Dash B so is for brute forcing. So for example, this tool finds out that this IP, this port has this vulnerable application installed, but the application implements form-based or HTTP basic authentication. Then if you choose dash B option, it also brute forces that particular application for default login and passwords. So that's useful as well. We have a very basic list in there, but you can also add your own list. It doesn't matter. Like, so I don't know if you can see this. I wanted to write a flow chart, like a nice program chart, and I started writing it in PPD, those shitty boxes, and then my wife walked past me, and basically she said, "This looks like a shitty flow chart," and so I asked her to write it, to create it for me, and then she came up with this Tetris-style flowchart. I don't think it's that visible, but I did not have the balls to remove it from my slide deck. What I did do was created this version, which I think is more visible, and I think we are okay now. This was a compromise. So initially, like I mentioned, it does port scanning, creates an XML output file, and then starts parsing that XML output file, looks for open web-based ports, read default path.csv file, and then creates an HTTP or HTTPS request, sends to the server. Before it does that, actually I'll talk about it later. Depending on what kind of response you get, so like if you get 400, then it looks if the page has a login attribute or username password attribute, and then ask you if you want to brute force that, and it just brute forces that. In case of 401, if you choose to brute force, it would brute force that and tell you if it found any of the default or weak login passwords. So in the end, you will get a table with a list of bunch of applications. Hey, this IP, this port has this application installed, and these are the default credentials, and also the exploitation path. So like currently we support all the applications from Metasploit, so it will give you path of exploit, so you can go to that path and just exploit it. We won't be supporting exploitation part, I suppose. We thought about it, but the reason is that we trust exploit from Metasploit, but then exploit and exploit DB for 12,000 applications. I don't want to run them on someone else's laptop. So what's in the box? So when you download the code, you get the main Ruby script, Yasuo.rb, response 200 Ruby script, which basically deals with all the brute forcing part and form-based authentication. Default pack.csv file. This is the core. It contains all the application signatures, and we are planning to update the format. Right now it's really simple, but we'll talk about it in a while. Like I said, it comes with a users.txt and pass.txt, which contains very primary basic list of usernames and passwords, but you can provide your own, and that will work too. Released under GPL. We wanted to make it really, really easy, so this is the current format of default path.csv file. So first column is the default, so the unique application signature, and the second column is the path to the exploit. Now we're planning to change the format to add a secondary signature, and then possibly create a JSON or YAML file for the default signatures. So what's happening behind the scenes is it detects false positives. So before it starts enumerating applications on a particular IP and port, it creates a bogus request. So I think it looks for this file will never exist .txt or PHP, and also similar kind of request or a folder just to enumerate, like some web servers just like throw 200 or 401 for each resource or garbage resource that you want to request. So like if it comes back with 200 or 401 for that particular file or folder, then we discard that. It automatically extracts the login form. So in case an application or server responds back with 200, It checks if that page has a login form or not. If it does, then extracts the login form, and also extracts the username and password parameters, and starts to brute force that if you select. All right. So we made some changes. So first of all, randomization. So we were talking about being stealthy, and the way it used to work was that, like I said, it creates a preliminary URL, so IP and port, and then starts reading application signatures from the default path, and then starts brute forcing that particular IP port. But it's not stealth, because if you have like 1,000 applications in default path.csv file, then it'll start sending at least 1,000 requests to that particular IP and port. So, which is not cool. So we added randomization. So now it randomizes the IP and port, so you're not attacking one particular IP or port all at the same time or for all the applications. So it randomizes that. So one IP port is being hit first, and then something else, and then something else. You know how randomization works. So more robust check for to detect false positives. We added some more checks to just figure out if we are hitting the right port and IP, and if there's an application running on that or not. Properly formatted output table. So we used to have a shitty output table. Now, thanks to Steven here, we have a pretty output table. We are constantly adding more application signatures. Try to make it our point to add some application signatures every now and then, because it's all about signatures. If we don't support more signatures, then we won't find more applications. So we added some signatures for IP cameras. So a while back, I did an assessment where I had to do testing of some IP-based cameras. So came across a bunch of them, found out the default signature of those IP cameras, and added them. This is the best part. So we try to keep it really simple in terms of format, so that people can add their own signature. So at one point of time, if you really want to be stealth, when I go on a pen test, my best new application or best new friend is the internal wiki of that particular company, right? So it's just there. It's unauthenticated. Once you're on a network, you can access it. It contains shit tons of data, relevant information. I've come across wiki pages with a whole list of like 5,000 databases, IP address, port number, database name, stuff like that. I've come across a page with application logins, default passwords. So, I mean, wiki is the way to go. And then so what you can do is you can do some own recon, like using RAR or some other tool, and then try to find out what technology that particular company uses, what kind of applications it installs. And what you can then do is wipe everything from default path file, and then just add the signature for those 2 or 3 particular applications, and find them across the whole network, and then pwn them. We cleaned up the code. It was a mess. It just used to fall off. So that's better now. And demo.
Can you see his screen?
Oh, yes.
All right. This is what it looks like with all the options and everything. So for the sake of demo, I've already scanned the 2 virtual hosts, and then saved the output in an XML file format. So I'm just going to use that for demo. And, so like I mentioned, if you don't want Yasuo to scan, you can just scan on your own and then provide the XML output using -F option.
Yeah, so this is good if you're coming back to a company for the second time and you have that scan data already. Or in my case, I've managed to find XML data. While testing, I managed to find an admin who already had an Nmap scan of their network just sitting in his home directory. So, yeah.
Helps you become more stealthy. I just ran the basic functionality, default functionality, and in the end, it gave me a table of all the IPs and the port number, all the applications installed, the exploitation path, and the credentials is not applicable because we did not brute force. Now, if I want to brute force, I can choose to only brute force HTTP basic authentication, or I can brute force form-based authentication. And the third option is to just brute force everything. Is it all visible from there?
Yes.
Okay.
Green's a little hard to see. Other than that, yeah.
So the green is all the good messages that you would want to see. Yeah. I know. So right now it says it found an application, started brute forcing, and then it says that found default credentials, Tomcat, obviously. You can get rid of all the debug messages. It's easy. It's like we just want a clean output. Anytime now.
How's everyone doing?
All right, done. Yeah, done. So demo works. So here in the table, you will see that IP address, port number, and the vulnerable application that it found. And then now you actually see the exploitation path and the default credentials. The first field is the username. The second field is the password. So in case of Tomcat, it found Tomcat. There's a second application called TestLink. I think it's test management application. Also allows remote code execution and file upload. Admin. For Jenkins, it's blank because Jenkins does not implement any username and password. So it's unauthenticated. That's even better. Then MediaWiki, also remote code execution, if I'm not wrong. And then default credentials, admin. In case of Zabbix, that guy installed Zabbix securely, so we did not find any credentials. So they were not admin. Yeah. I think the Apache Tomcat, like I had to include it in the demo because like I seriously think that the Tomcat installs itself on the network. Like, I mean, that is a very, very...
Sometimes a few parts that it's incorrect. Does it actually test for the default password, or does it show you only?
It tests for
It tests. It brute forces that if you choose to. Right, so like, there's no way that, like, Apache Tomcat is a very well-known vulnerability in the application, and I mean, it's been out there for so many years. If you look at Metasploit, there are, I don't know, like 5 ways of exploit it, and I refuse to believe that someone misconfigures it even now and on multiple instances. Right, I think it just installed itself on the network, and if that's not true, I'm pretty sure that it reverts back to the default credentials once an admin configures a strong credentials. Yeah, that's it. Some challenges that we faced, like I said initially, when we thought of writing this thing, we thought it would be so easy, we can just write it. So one point here is that the generic vulnerability scanners won't find the applications, not more than 20% of all the applications, because you need signatures. And so in some cases, they could tell you that application has, there's an application here, and maybe it's configured with default login credential, but that doesn't mean that the application is vulnerable or exploitable. Right? So like not all applications are vulnerable or exploitable. So we're basically looking for applications which are vulnerable and exploitable, so that we can very quickly pwn the network using those applications. So some challenges that we came across was that ExploitDB is a great resource, but there's no consistency in how you submit the exploits or vulnerabilities. So sometimes you will see that the application name is there and then the version number. Sometimes application name bracket version number. Sometimes no application name, just the version number, so on and so forth. So it's not easy to parse data from there.
So, being the low man on the totem pole, I was tasked with trying to figure out how to do this. I spent days trying to figure out how to do this, as well as, since we're using the unique path that applications may install as our primary signature, which aren't in the file, it would have to go through each and every exploit, download it, check it, and pull that information out. I wasn't going to do that, I'm sorry. That would take too much time. If anybody has a team of interns that they're willing to lend us, I have work for them. If not, it'll just be a slow process. But yeah, 3 days trying to figure out a nice programmatic way to do this with, unfortunately, no success. So, if anybody has any ideas of how they might be able to do this, please let us know.
He doesn't know. He'll have to do it. The other challenge what we had was that when we dynamically extract the login page username and password, it's obviously always going to be based on a filter or regex pattern, right? So if your page is in French or any other language, it's just going to bum out. It's not going to work. So yeah, we try to keep just keep our projects within the US and not go to UK or French or France or something. Some future development. We want to implement smarter version detection, which currently is not there. Support mass scan output. I think we support mass scan output now, but not by default. I think there's an switch in mass scan that you have to use that will generate the right output format. So you can use that and do mass pwnage on the internet. Not that I'm recommending it, not at all now. Add support for more vulnerable applications. That's always be the case. And add secondary signature. Like I said, we want to migrate from the current format to a more 21st century format. I think we'll try to create a YAML file or JSON file, add a secondary signature, and probably a string to match if you find the page. The code is modular now. We are also planning to convert this into a gem, so you could just install it, and that will be that. Add multi-threading. You want to talk about it?
So the timelines we gave you with like the 2 hours, that's on a single thread. We're not very good programmers, so we haven't quite figured out how to do multi-threading nicely for it. We also plan to change the way we do passwords. We might look into DPE as well as changing the format from a user file and a password file to a single file that has user password combinations, so you can help narrow down to, you can give an application, hey, these are the default creds for this application, try nothing else. Or maybe try like a top 10 common passwords for it. So that's kind of what's in the works for that as well.
Add support for vFeed. vFeed is a vulnerability aggregator, which is pretty awesome. At this point of time, I'm not sure if we can or not, but we'll look into the possibility of doing that. I've already mentioned that we want to migrate from the CSV file to YAML or JSON. I don't have any preference. Cry for help. Like I said, signatures are all we need, and he's going to do some of the work for sure, but I can't hire more interns at this point of time. So if you guys come across any application signatures, there's got to be a better way of doing it, but at this point of time, you can post a comment on GitHub, just contribute to the GitHub, or drop us an email, send a pigeon, everything works. Yeah. So, yeah, I want to emphasize on that. If you come across application signatures that are unique, feel free to post it here. That would be really helpful. And that's pretty much it. Questions?
How do people submit signatures to you? Via email or do you have a form based?
Email, GitHub comments, Twitter,
Yeah.
Fire Pigeon.
Yeah, leave a comment on GitHub, or you can pull the file from GitHub and then contribute to the default CSV file and then add it, and then, yeah. And you can download the code from here, and you can send all the abuse to Steven. The Twitter ID there. He's used to it. All right, and credit to Nmap, exploit database. My colleague Ram, who's working on making it into a gem and added some more coolness to the tool, and Google Image Cache. Thank you all for coming.